Start in about 5 minutes. Any math questions that you have, you got 3 ways to ask them. Oh, hello, Internet, and happy Thursday night. I'm Joey, your favorite math teacher. Welcome to Everyone Loves Math. I'm going to take a second to tell you a little bit about this website, this stream that you're watching. It's connected to a website. That's actually the first thing I should tell you. EveryoneLovesMath.com. Totally a website. It's totally real. Look at this. Ready? Boom. There it is. EveryoneLovesMath.com. So I'm Joey. I'm the founder of Everyone Loves Math. This website is something that I've started to build from the ground up to be like the website for students from grade 5 up through calculus. I offer private tutoring. I offer this Twitch show. And there's a couple of other treats that are coming up. I'm still kind of revealing some of the stuff that I'm doing. But I do want to show you a couple things before we get to our math problems this evening. All right. So a couple things to show you. Everyone Loves Math website. You go up here, boom, boom. One-to-one tutoring. That's my link to private tutoring. I've made a cute little video for you. But you can book a tutoring session with me. You can do that today for like next week. It's totally there. Other thing, I've got message boards. If you need help with math, you can totally join my message boards and post questions. Those questions will either get answered like I shouldn't say in real time, but they'll either get answered by me over the message boards or someone else on Everyone Loves Math, or they can also be featured during our live show. I have 2 levels of subscriber. I do have a free level and a $5 a month level. Honestly, right now, $5 a month gets a little VIP room, and that's about it. Your $5 is really about supporting my site and the work that I'm doing. And I'm going to try to keep all of this as accessible and free as possible. All right, so the other thing I should point out, just because I'm excited, I made a merch page. This is kind of wild. So if you go and click the merch link, you'll see that I have some merch up there, and it looks, I don't know why it does this. It looks like stickers, but there's like some cool stuff on here, man. Let me show you. I'm going to sell you my stuff. Look at this. So I got a sticker, right? But if you scroll down, you'll see other stuff that I made. Wait, where is it? You'll see other stuff I made, like I totally promise. Where is it? Like a pullover hoodie, man, or a throw pillow. Who wouldn't want a bright green Everyone Loves Math throw pillow? Do you have a relative that you dislike? Perfect. Perfect birthday present right there. All right, so I wanted to show you that. All of that having been said, there is 2 pieces of business that we have to get to before we get to our new problems for tonight. Merch, man. Merch. All right, so there's 2 things I have to address from yesterday. Thing number 1. I did a problem where I didn't get the answer that was in the multiple choice. I'm going to tell you right now, whoever wrote that problem, they put a different answer in the multiple choice than the question that they asked. It was their fault, not mine. I'm going to tell you right now, it was their fault, not mine, and you know that's true. Search it in your heart, you know that to be true. All right, second thing that we have to discuss. Music. So it got to be about 6:30 yesterday, and I realized that I didn't have any music for my stream. So I went on YouTube Music, and I figured, all right, let's pick some Mozart, because, you know, that's classy. It's classy Mozart. And I also kind of figured that Mozart would be, oh, I don't know, like royalty free. So it turns out I got all these like claims on Twitch about like violating the copyright. I'm like, who is getting Mozart been dead? Who's getting his money? So I guess it turns out if you make your own arrangement of a Mozart song, then you can get money, which to me sounds like a total scam. Also, the song that I heard was the bum, 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 and it sounded the same as what I've always heard it to be. I heard no arranging. So Mozart, I'm going to tell you right now, I know this to be true to everyone else, but you're dead to me. And that's why I'm going to crank up my beats here. That's why you've been listening to this, right? All right, cut that off. So what I did in a fit of panic, is I grabbed my synthesizer and I made the cheesiest beat that I could. I wanted a beat that sounded like a math teacher made it, and I think I got there. So we've solved the music. We're not going to hear Mozart. We're not going to get sued by Mozart. Fix that. And thing number 2 is we got an answer to that weird COVID problem from yesterday that I knew I didn't get wrong. All right, that having been said, it's time to boogie. Let's do some problems. I want to do some problems. So once again, if you want to suggest any of your problems, you can ask a question in Twitch chat. You can go to the phone number, that phone number that's scrolling right there. That's the Everyone Loves Math hotline. Operators are not standing by, but it is a Google, a little Google voice thingy where you can ask questions and I can get them answered. So, that's exactly what we're going to do. All right, so let's boogie. Actually, see a question right now in there. We're going to get there after the first group of 3 questions. We're going to do 3 questions and we're going to get to that one, all right? Let's see here. Answers, A, B, C, D. Oh, cool. All right. Actually, you know what? Let's go straight to the one from the chat. Why not, right? So, I'm going to copy this down so that this is up here. But we've got 2 functions. We got a f of x equals 3x squared. And we've got a g of x equals the sine of x and then plus x. And they kind of put this in parentheses just so you know it's not like a x plus x. Okay? And then what they ask us to do is they ask us to find, they want us to find, and then they write this. Fg in parentheses x. All right, so that's the problem. This would be a problem in like anything past algebra, algebra 2, pre-calculus, college algebra, all the way up through calculus. You're going to have to do a problem like this. So let's talk about this problem for just a second. All we really need to know is what the heck this thing means. What's it mean when... Oh my god, that is the worst highlighter color I've ever used. Oh my god, why would you even have that as a highlighter color? What is even happening right now? Did you all see that? All right, can't I delete this? That's the sickness. That's the sickness coming back. All right, so let's talk about this thing. We need to know what the heck this means. What does that mean? So the first thing we have to assume, caller, is that the teacher that asked this, oh, you can't see the problem. I'm trying to solve a problem. Look at this. Oh my goodness. Yo, let's do it. All right, looks like I also have to bring this down a little bit. So let's bring everything down just a little bit so everybody can see everything. That's what we're gonna do. All right. Boom, 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 boom. There we go. All right. So, what we are going to do now, we are back in the game. All right, so we're going to talk about what this thing means. Now, what we have to do is we have to assume that the teacher asked you this and he or she asked you this in a very specific way. Because FG next to each other with no symbols, this means multiplication. So just like if we had 7x next to each other, 7x means 7 times x. FG means multiply f and g. And if we wanted to write this out, which I totally would suggest doing, if we wanted to write this out as to what this actually means, here's what this actually means. Let's take care of this. So this actually means f of x times g of x. That's what that means, if the f and g are right next to each other with no symbol. So in order to get this answer, we just have to substitute 3x squared for f of x, right? Because up here, that's what it says. F of x is 3x squared. And then for g of x, let's see, g of x is this more complicated thing. I better put that in parentheses. Sine of x plus x, right? And if I want to be really careful, I can do that, just to make sure that everything's like packaged up super careful. If this was one of the multiple choice options, this would be the answer. But the person that sent this in, there's multiple choice, and the way that they got the multiple choice was just distributing this 3x squared. So they just did the little, what I think every math teacher calls the rainbows, did the rainbows. So let's do it. 3x squared times the sine of x is 3x squared sine x. And then 3x squared times x is 3x to the third. And so that would be the answer. Let me put my cute little, gotta put my cute little bubble around it. Man, where am I without putting a bubble? So, person that asked that, you are the first person that sent in a problem to the hotline. That's awesome, man. Welcome. Thank you for being our first hotline customer. Hope that helped. Boom, baby. All right. So that having been said, now we're going to go back and do a couple of prepackaged problems. If you have any other ones that you wanted to see done, then please just let me know and I got you. All right. So let's boogie. We're going to boogie right now. How about this? Let's see. So this problem, is this hard to see? This might be hard to see. So we got a graph here. And what they're telling us is they're telling us the function, the equation of this graph. And I'm going to write it bigger. They're telling us, nope, can't have red. Can't do it. Can't do it. That's how the demons come in. Can't do red. All right, so it tells us that g of x is a times x plus 3 squared minus 5. All right. So what it asks is it asks, just by looking at this graph, what is the value for a? And so I thought this was a really interesting problem because we can talk about being what I like to call mathematically stubborn. With this problem, I think, a lot of times people get intimidated about it. But if we have an equation and they're asking us for one of the variables, right? They're asking us to find a. All we need to do is make sure that a ends up being the only variable in this equation. So we need to put something in for g of x, because that's a variable, and we need to put something in for x. So we need an x and a g of x that go together. And here's the great thing. You can pick almost any point on this graph, and it's going to give you an x and a g of x that you can stick in. In fact, and I mean, this is one of those things where I can just give you this advice because I've done this for a hot second. You can pick any point on this parabola, right? That U-shaped parabola, any point except the vertex. So I'm going to pick, I don't know. Let me go over here and look. Let's pick an easy point. How about this point right there? That looks to me to be the point 1, 2. So the point 1, 2 is on this parabola. What that means is when x is 1, g of x is 2. right? Because g of x, that's just the output, that's the y value. So what we just learned is that when x is 1, g of x is 2, we can use those numbers to plug up those variables, and then we can solve this no problem. Let's do it. So g of x is 2. I'm going to put a 2 in. Remember, a is what we're trying to find. X is 1, so I'm going to put that in. And my life just got a whole lot easier looking. Look at that. I can do this. I can do this all day, man. So let's see. We'll clean up. Let's see. The 2 is going to hang out, right? I don't know about that. 1 plus 3. I know that one. That's 4. And 4 squared is 16. So this is going to be 16a minus 5. So if we're down here, we're all the way down to a two-step equation, right? We're back in Algebra 1. You can do this all day, man. Algebra 1, boom. What am I going to do? I'm going to add 5 to both sides. So if we add 5 to both sides, boom, boop, 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 we get a 7. And then 7 equals 16a. And so a equals 7/16. Alrighty. Boop, boo, doop, boo, doo, boop, boo, boo, doop, boop, boo, 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 doop. And again, we get something that's not one of those answers. What's the value of a? So what I'm going to say is somebody keeps playing with us with these answers, because that ain't cool, man. That ain't cool. That ain't cool. All right, we're going to move on. This is what I get from just picking problems from the internet. You know what I mean? All right, let's pick a problem we can trust. Let's pick a problem we can trust. I wanted to do this problem. I thought this problem was cool, so we're going to do this problem. This is an algebra. Gosh, this would be a really hard algebra 2 problem. So I'm going to guess that this is like a pre-calculus problem. But what this has is, this is one of those rational functions. So we've got a function that is a fraction right up there. And these are those weird things with the like asymptotes and stuff. So what they're asking us in this problem is to find a bunch of stuff. They want us to find the domain, the range, x-intercepts, y-intercepts, any vertical, horizontal, slant asymptotes, or holes. Yo, so much to find. So much. In fact, there's so much to find. I mean, I kind of want to cheat and put this into Desmos. And we totally could. We totally could, because we're at home. Nobody's seeing what we're doing. We could put this into Desmos. And trust me, put it into Desmos, you're still going to learn something. But I'm going to hold off on it, even though that's where my instincts are. I'm going to hold off on it. We're going to do this problem the other way together. All right. So let's knock some of these out. We're going to knock some of these out. All right, okay? So the first one, let's see. I like to start, I don't know, the y-intercept. Y-intercepts are pretty easy. I mean, we could pick anywhere that we want to go. Let's pick the y-intercept. I'm going to find that first. Why am I going to find the y-intercept? Because the y-intercept is always where x equals 0. So if I look in this function, I'm really doing f of 0, which would be this big old fraction, 0 squared minus 9 times 0 plus 11 over 0 minus 3. And we'll do our little magic there. So what do we end up with? 11 up top and negative 3 on the bottom. So what that tells us is our y-intercept is the point where x equals 0 and y is negative 11 thirds. So that's right around negative 4, right? Because negative 4 would be negative 12 thirds. You know what I'm saying? All right, so we found a y-intercept. I did that because that's like the easiest thing to find. That's why I did that. All right, let's talk about x-intercept. How about that? So the x-intercept is always where y equals 0. And this is something that you probably hear in middle school, 8th grade, 9th grade, and it just stays true, man. It's one of those things, it stays true. It's good old-fashioned math. You know, it's like Werther's Original Candies. All right, so let's do it. We want to know where y equals 0. So that's going to be 0 equals this ugly fraction. Oh boy. X squared minus 9x plus 11 is on the top, and then x minus 3 is on the bottom. Okay, so now we got to figure out, all right, where does this fraction equal 0? So the easiest thing to know is that a fraction equals 0 where its numerator equals 0. The only way you get a fraction equal 0 is if you have 0 divided by something. So what that tells us is, I'm just going to scroll down here a little, that tells us that the numerator has to be 0. All right. Well, what are we looking at here? We're looking at, again, man, this is like good old, maybe tonight's like old-fashioned night. This is a good old-fashioned quadratic equation, right? X squared minus 9x plus 11. If you're an Algebra 2 or a pre-calculus student, you probably can look at that and tell that doesn't factor. If you're an Algebra 1 student, stay tuned because my first YouTube series is going to be on factoring. So since it doesn't factor and I'm feeling saucy, let's do the quadratic formula. All right, it's been a minute since I've done the quadratic formula. Let's do it. What are we going to do? We're going to be like x equals. All right. So remember here, quadratic formula, a is 1, b is -9, and c is 11. Let's see. I have to write it out, the quadratic formula, because all y'all are saying it in your head, right? Opposite of b, plus or minus the square root of the quantity b squared minus 4ac. What's that denominator? Y'all say it out loud. Scare your cat. 2a. There's the quadratic formula, right? You memorize that, you get that tattoo, and you're set for life, man. That's the tattoo right here, right here. Get it right there. All right. I don't even know what they would do if you walked in with that, like to a test. Be like, it's my tattoo. What are we gonna do? All right. So now what we got to do is stick 1 in for A, -9 in for B, and 11 in for C, and then beep boop bop. We'll do that. All right. We'll do the beep boops. So here we go. X equals. All right. B is -9, so the opposite B is 9. Then we get plus or minus the square root of b squared, so that's -9 squared, which is 81, minus 4 times 1 times 11. 4 times A times C. And then we're going to do all divided by 2A, 2 times 1. All right, man, we're getting there. We're getting real close. Let's see. I think we can clean this up. You know, this is a graph, so we actually want to like plot it, but let's see what we can do. I'm going to write x equals. We're going to do 9 plus or minus the square root. So what do we got? We got 81 minus 44. Now listen, I know we did this last night. We went over this. It's 9:20 at night. That's too late for me to do mental math. All right, you get me in the morning, I'll do this in my head, no problem. But 9:20 at night, I'm going to do 81 minus 44 on my calculator and get 37. I just don't want to do something silly in front of all you people, you know what I mean? All right, so let's stop here for a minute. 9 plus or minus the square root of 37 over 2. That's disgusting. First of all, I'm sorry. It's disgusting. But you also need to know a couple things. That represents two different numbers, right? 9 plus the square root of 37 over 2, and 9 minus the square root of 37 over 2. So it represents two numbers. And remember, those numbers were the x-intercepts. Remember, way back up here. Let me go way back up here. Remember, we're the x-intercept where y equals 0. So now we got 9 plus or minus the square root of... Okay, watch what we got to write. Remember, the x-intercept is where y equals 0. So the x-intercepts are going to be 9 plus the square root of 37 over 2, comma 0. Remember, the y is 0, right? I know you can't see that, but this isn't your homework. You're okay. I said it out loud. You can read it. And then 9 minus the square root of 37 over 2, comma 0. Now, those are the exact x-intercepts. Exact x-intercepts. We'll find the approximate x-intercepts in a minute. All right, I see you, N. Stucky. What's good with you? N. Stucky. All right, so we got x-intercepts, we got y-intercepts. You ready for asymptote time? Oh, and if you've never heard that word, it's not a curse word. All right, I don't curse on this site. There will be no cursing on purpose. Asymptote. That's what these are talking about. The A's right here, these are the asymptotes. Asymptotes. All right, so let's find some asymptotes. All right, so asymptotes, let's see. So if we go back and look at this original problem, right, this numerator doesn't factor. The denominator doesn't factor. All right, they both don't factor. So we don't have to do anything tricky. We know that the asymptotes, like look at 3, look at the denominator. What would happen if x was 3? If x was 3, we'd have 3 minus 3 equals 0. That'd be bad. That'd be bad. We'd have some number divided by 0. That'd be bad. That's a vertical asymptote. So the vertical asymptote is going to be x equals 3. That's a line. All right. Stucky. Bum around Twitch, man. It's all good. Stucky, this is where we're going to do a little math Q&A. So if Stucky ever has some math homework, come on by, Stucky. All right, so let's talk now horizontal slant asymptotes. So this is where you got to know that the vertical asymptotes are where like the function explodes. The horizontal asymptotes and the slant asymptotes is what happens way out here. What happens when x is huge or when x is really small. And to figure those out, we have to look at the numerator and denominator. Because I kind of think about this being like a horse race. All right. And this is going to be, we'll see if this works if you don't know what a horse race is. But I barely know what a horse race is myself. But let's talk. So when we're talking about asymptotes, all right, let's talk about asymptotes. I love talking asymptotes about asymptotes. Okay, that happens all the time when we have a rational expression. So a fraction expression, right? And we have like a x to the some kind of n, and then, you know, there's like a number out front, and then it's like x to the n minus 1, right? And a number out front, right? So like there's all these, you know, x minus 2, ... Okay? And then in the denominator, we could have like, we could have like q x to the m plus r x to the m minus 1 plus qrs x to the m minus 2, and etc. Okay? That looks disgusting. But this is what all of these problems look like. Is it's some polynomial on the top, like a quadratic or some business, and then some polynomial on the bottom. So here's what you do, man. You look at the exponents. All right? You look at the exponents. And this would be in the notes of like every pre-calc kid or adult. We gotta have this. So if, let's see, here's what we're gonna do. So if the numerator degree is bigger, so if n is bigger than m, then there's going to be no horizontal asymptotes. If the numerator wins, then this fraction keeps getting bigger and bigger and bigger forever. That's really what it means, right? If a numerator is bigger, that means the number gets bigger. That means this thing keeps blowing up and blowing up and blowing up. There's no horizontal asymptote. If m, the denominator degree, is bigger than the numerator, then the horizontal asymptote is at y equals 0. Because if the denominator wins for big values of x's, if the denominator wins, think about fractions that have big denominators. They're really close to 0. All right, then the last possibility, if n and m are equal, then there's a horizontal asymptote at the fraction y equals, and I just picked these letters out of my butt, a over q. Where'd I get that? That's what I like to call the photo finish. So if the degrees up top and up on the bottom, if n and m have the same number, then we look at the fraction of what we call the leading coefficients. All right. Well, that was a long walk, wasn't it? That was fun. We'll do a little bit more of that later. So if I come up here, what do I know about this thing? Oh my, you can tell I rambled because I got to scroll all the way up there. Well, look at the degrees. The numerator has a degree of 2, x squared. The denominator has a degree of 1. So that means the degree of the numerator is bigger than the degree of the denominator. There are no horizontal asymptotes. All right. Last is the slant asymptote. And the slant asymptote is one more thing we have to add here. So here's what we're going to add. If, all right, we got to do this. If n, the numerator degree, is 1 bigger than the denominator degree, which is what we have here, then there's a slant asymptote. And we get to do long division to find it. See, that's why I love this problem. Is y'all thought you were tuning into Twitch, y'all could be watching somebody playing, you know, what is that? Battleborn, Beastborn, Battle Swords, Swordborn. But instead, you're with me, and I appreciate that. That's awesome. All right, so we get to do long division together. It's going to be great. I'm way into long division. I'm way into it, although my memory is horrible. So I'm going to go back up here and look at it because I forgot. All right, x squared minus 9x plus 11. Oh man, this is going to be awesome. Y'all ready for long division? All right, x squared minus 9x plus 11. And we're going to divide it by x minus 3. We're really just taking the numerator divided by the denominator. We're rewriting this function. All right, so I'm going to do this long division. If you want to see a video on long division, you got to ask me in one of those ways. Go to the message boards. I'll do a video on long division, post it, and we'll spend some real quality time and talk about long division. All right, long division time. Here we go. Boom, boom. X goes into x squared x times. X times x is x squared. X times minus 3 is minus 3x. So we did the goes into step, the multiply. Now we subtract. And if you've never seen this before, this is the same as like 4th grade long division. It just looks ridiculous. All right, so subtract x squared minus x squared. Bye-bye. Negative 9x minus negative 3x. Be careful here, right? Minus negative 3x. All right, so we have negative 9 plus 3. You know what I'm saying? So that negative 9 plus 3, that's going to be negative 6x. Negative 9 plus 3. Don't get it twisted. And then plus 11. All right, look at us. Look at us doing long division. On a Thursday night with a polynomial. X goes into negative 6x. Negative 6 times. I know that because negative 6 times x is negative 6x. Negative 6 times negative 3, that's positive 18. And we just did the goes into step, multiply. Now we're going to subtract. Again, all the same steps from like 4th grade. It's just with this disgusting monstrosity. All right, so if we subtract, what do we get? Well, the negative 6x minus negative 6x, that goes away. We did that on purpose. And then we have 11 minus 18, right? Because, again, you got to be careful. That's a minus times positive. So that's 11 minus 18. And I know 11 take away 18 is negative 7. And so if we're going to do our long division, again, same as we did in 4th grade. We write minus 7 over x minus 3. Like, it's so similar. I'm going to tell you this. It's so similar to like 4th grade stuff. I can't even remember what you call it. Is that like the quotient or the dividend? All those words that like, I don't remember. Okay, so now we can go back and talk about the slant asymptote, because here's kind of the cool thing that happens. If you look at this function, I'm going to circle it right here. So this function, x minus 6 minus 7 over x minus 3, that is the same as the original function. All we did was we just did long division. It didn't change anything. We rewrote it in a different form. Now remember, slant asymptotes are also what happens when x is really, really big. And one thing that I know is that when x is really, really big, this thing right here gets really, really small. How do I know? Because think about it. If x was 1,000, this would be 7 over 997. That's a really small number. And if you put a big enough value for x, this thing just disappears. It turns into 0. What that means is the thing that we're left with, x minus 6, that's the equation of the slant asymptote. So the slant asymptote is going to be the equation y equals x minus 6. Okay. All right, and then finally, I'm going to tell you there are no holes. The reason why we know there are no holes is there was nothing in this original problem that factored and like canceled. That's how you get holes. Okay, so we've done everything but the domain and range. Everything but. So what we're going to do now, because I have the marker, is we're going to go to Desmos, and we're going to see how all this stuff comes together. Because if I was a student doing this problem at home, I would want to be playing with this and just kind of breaking it down and putting it back together, see how it works. So let's do that. We're going to go to Desmos, get our graph on. Okay? Let's see here. All right, there we are in Desmos. So what I'm going to do right now in Desmos is I'm going to hit the fraction button, the division bar, and now I'm going to just type in x squared minus 9x plus 11. And then our denominator is going to be x minus 3. All right. And when you do that, the first thing you might say is, oh my god, it's so ugly. Well, okay, sure. Yeah, that's what it looks like, all right? It was born that way. Be nice to it. All right, be nice to it. So let's talk about some things. We're going to talk about some things. They're going to be great. So how about this right there? I see this dot. I'm going to click on it. 0, negative 3.667. Guess what that is? That's the y-intercept. Remember we did when x was 0, y is whatever it was, like negative 11 thirds or something? Yo, that's negative 11 thirds. There it is. All right. Now let's talk about this thing, that thing, 7.541, 0. That's an x-intercept. And what does that happen to be? That happens to be, I know this for a fact, 9 plus the square root of 37 divided by 2. How wild is that? We did the work. So if we go to our calculator and do 9 plus the square root of 37 divided by 2, I bet you we get 7.5 garbage. And if we did 9 minus the square root of 37 divided by 2, I bet we get that garbage right over there. So that's the what the x and the y-intercept mean for us. All right, so now let's talk about more stuff here. I'm going to zoom out a little. We did have a vertical asymptote. That vertical asymptote was at the line x equals 3. Now, what I like to do is I'm going to set this up as a dotted line because that's what we often do, is we often show asymptotes as dotted lines. And look at this. Does that look like our function is approaching that dotted line but never touching it? You bet. Vertical asymptote at x equals 3. Oh, yeah, baby. All right, let's talk about slant asymptote. What did we have? Didn't we have y equals x minus 6? Right? Remember that? We had x minus 6 and then it had all that garbage after it. So I'm going to make that a dotted line. I do that just by clicking and holding on the little color there. And if I zoom out, look at this thing. Does that look like some asymptotic behavior to you? Oh, yeah. Oh, look at that. Oh, look how close. Oh, so close. They're getting closer and closer as you go out there. Guys, and girls, we took care of this problem, man. We whooped this problem's butt. This is exactly what this function looks like. All right, groovy. What I'm going to do is I'm going to take a quick water break and return soon. Y'all get to listen. Oh, let's get it up. Y'all get to listen to my whack drum beat for about 3 minutes, and then we'll be back. All right, y'all stay classy out there. We'll be right back. Thank you for digging the music. Those are my funky jams for my synth, man. My funky synth jams. What's up, everybody? Welcome back. Wanted to talk about a couple things before we get into the second half of our show. I'm having a good time. I don't know about you guys. I'm having a good time. I'm feeling it. All right. Let's do a shameless plug. What's up, everybody? Shameless plug. Once again, for those of y'all just joining, I'm Joey. I'm the founder of a website called everyonelovesmath.com. It's going to be the world's best website for math. It's going to be the best. You know it's going to be the best. Everyonelovesmath.com. I'm going to say it again. Take that, all of you .org, .biz, .info, all y'all people. It's about the .com still. Everyonelovesmath.com. So you go to Everyone Loves Math. If you want to see my beautiful face, you can click up here and be like, oh, tell me about Joey. And there's my beautiful face. Look at that. Look how happy I look, right? Good looking guy. What can we do? We can go to one-to-one tutoring. Oh, I got private tutoring online. You can book a session in Calendly. We can do some private tutoring next week. The message boards. I've got 2 different levels on my message boards. I've got a free level and a supporter level. And I'm going to tell you right now the only difference between the two. The supporter level is $5. You get a VIP room to ask questions. And really, most importantly, it supports me. It supports the work that we're doing here. So if you believe that we should have like an outlet for people to ask questions about math and get some math help, that's a way to support, is to go and be an ELM supporter on Everyone Loves Math. Of course, if you get a free plan, I still love you. It's all good. I really, what the plan is the plan is to bring the math to the people and then hopefully have like, some kind of sugar daddy or sugar mama just like, buy me up and have me do math in their pocket all day and still be able to come onto Twitch at night. Did that come out creepy? I think that might have come out creepy. Okay. Well, that having been said, let's see, I'm waiting for the viewer count to go down. Okay, it didn't, so I'm safe. That having been said, we're going to get back into it. Second half. All right, here we go. Boom, boom. There we go. So, what do we got? Oh, look at this. Oof, we got some exponential garbage. And when I looked online, the person that was doing this they knew they needed to use logarithms. So, okay, we're going to use logarithms. Now, with this thing, if you're using logarithms, you're going to have a bad time because 4 and 6 in the world of logarithms, 4 and 6, those aren't like powers of the same number or anything. If it was like 4 and 16, you might be able to, do a little something. All right. Stucky, I'll tell you in a sec. What's up, Stucky? So Stucky asked a question. I'm gonna answer Stucky's question, then I'm gonna go back. So I checked the message boards to populate the questions for Everyone Loves Math. I also grabbed stuff off of Reddit. The more questions that get asked on my message boards or through the ELM hotline, the less I have to go to Reddit and just answer the questions that you want to have answered. So really, Stucky, the questions that I have up right now, these are dummy questions just for me to work through while I wait to get some of your questions. So if you're in a math class and you got math questions, submit them. Put them in the Twitch chat, put them on the message boards, or send them to my Google Voice number, also known as the Everyone Loves Math hotline. All right, so that having been said, we got a few more problems to do tonight, so we're going to knock out a few more problems before 10. So with this problem, 4 and 6. 4 and 6 not having like a common base, we're just going to take the logarithm base 10 of both sides. We could take the log base whatever of both sides. It's really not going to matter. But I'm going to guess that like most people around, I'm going to move this up just a little. I guess I'll leave it there. So most people around would want to take the log base 10 of both sides. So that's what we're going to do. We're going to take the log base 10 of both sides. That is absolutely a legal move. Now, from here on out, we have to use some properties of logarithms. And again, one thing that I love about the show is, our ability to mix it up. So we're going to mix it up. Logarithm time. All right, so with our rules of logarithms, when we have a log of something to a power, we're allowed to bring that power down and turn it into a multiplication problem. So I'm going to take that x squared minus 9 and bring it down and multiply that by the log of 4. And again, we're using base 10. That's why I'm not putting log base 10, because you don't put the base when it's base 10. You know that. You know that, twitch.tv/everyone loves math. You know that. All right, so over on the right side, we're also going to bring down the exponent. The only difference with this problem is the exponent's ugly. It's like not, 2. It's, x squared minus 9 and x plus 3. Oh, well. We'll still bring down the exponent and turn it into a multiplication problem. That's one of the fundamental properties of logarithms. All right, so now we have to get x by itself. And here's where things get a little funky, right? So almost always with these problems, if they look funky, there's probably a trick. And this one most definitely has a trick to it. And this is just it's really the have you been paying attention trick. X squared minus 9. That is a difference of two squares. That's x plus 3, x minus 3. So if you are in a class where you're doing logarithms, then you've been doing polynomials long enough to where you should be able to kind of pop those off. And if you can't, get with me. I got you. We'll do some math squats. Get you in shape. All right. So in that step, all I really did was multiply or factor the x squared minus 9. So the reason why I did all that is, oh, look, there's an x plus 3 on both sides. So if we divide both sides by x plus 3, right, doop, and divide this side by x plus 3, then we'll see the x plus 3's cancel out, and this equation gets a little bit easier. If we want to go a little bit easier still, which I do, I don't want to rewrite this a million times, I'm also going to divide by the log of 4 on both sides. I'm going to do that because there's going to be some more canceling that happens. Let me use a different color. Look at that. There's a log of 4 in the numerator and a log of 4 in the denominator. So if we do all that business, we end up with x minus 3. That's the only thing remaining over there on the left side. Only thing remaining. And on the right side, we get the log of 6 over the log of 4. Now this problem is one step from being done. We add 3 to both sides, and we end up with x equals the log of 6 over the log of 4 plus 3. Remember, we added 3 to both sides. Now, there are other ways we could write that answer. And if this was multiple choice, we might have to do a little bit more thinking. But it's not multiple choice. We're done. We found x. Look at us. I'm proud of us. All right. Here we go. Let's switch it up. Oh my God, that's so tiny, isn't it? All right. All right. Here's where I try to make this. I'm going to try to make this bigger for you. And it's going to end up making me cry. Watch. I know I'm going to... Oh, boy, that got so much bigger. Okay. Are we looking there? Are we looking good there? Okay. All right. That's looking better. So I caught this problem. Is this person asked this question? Oh, and the ink went invisible. It's the internet. Okay. So this person was saying, I might be stupid. They're not. I might be stupid, or could it be that I just spaced out in class in the explanation, but I don't understand where the 1 comes from, this 1 that's right here. Let me circle this. So they say they don't understand where this 1 comes from, and they want to know what happened to the sine squared plus cosine squared. All right, so that's what they're asking. So we're going to solve this problem for them, because this is one of those neat little geometry, trigonometry things. Yeah, you're not stupid. So where did the 1 come from? The 1 came from the fact that the sine squared of x plus the cosine squared of x for any angle is 1. And what I would like to do is I would like to spend a moment just proving that with you. We're going to prove it, okay? So we're going to do that by, I'm going to pick an angle at random on the unit circle. All right, and again, if you're in this class, you know what the unit circle is. If you're in geometry, get ready, because you're going to learn about the unit circle. All right, so let's draw a picture. All right, so I'm going to draw this picture. Here we go. Here's my beautiful picture. Oh my gosh, this is the first time I'm trying to draw a picture on this. Oh boy, that's a circle. That is a perfect circle. Michelangelo just came in here and drew that. Okay, and if anyone says anything else, you're banned. You're banned. Okay, so I'm going to pick just kind of randomly a point on that circle, and I'm going to make an angle connecting the origin to that point. Right? This is some real trigonometry stuff. Boom. And just for kicks, let's call this angle x. I'm going to call that angle x because we're proving something about the sine squared of x and the cosine squared of x. Okay, so now we just need to label the three sides of this triangle. So let's label the three sides of this triangle. So I'm going to say, let's see, maybe we'll use red for the sides. So the hypotenuse of that triangle also is the radius of the circle. So I'm going to call it r. All right, and then for the sides, oh, what am I going to do? I'll call them A and B. How about that? I could pick any other letter I want except X, because X is in the problem. But I'm just trying to pick easy, A and B, man. I'm just trying to keep it easy. All right, so what do we know? Well, now let's actually bust this out. I'm going to go give us a little bit more space. Now let's actually talk about what is the sine squared of x. So the sine squared of x means, can't use red. Boom. So the sine squared of x really means the sine of x squared. That's what the sine squared means. It means the sine of x squared. The cosine squared of x really means the cosine of x squared. All right, so there we are, sine squared of x plus the cosine squared of x. Now let's look at our picture. So our picture, you should know that the sine of x is a fraction. It's the, what do we call it? Sine is opposite over hypotenuse. So for this fraction, for x, opposite would be b. That's the side opposite the angle. And then the hypotenuse would be r. So we'd have b over r squared. Okay. I know what you're saying. If you've never seen this before, you're like, where's this going? Trust me, it's going somewhere. It's going somewhere quick. All right, let's talk cosine. So the cosine is, what do we call that? Adjacent over hypotenuse, right? So that would be a over r. Again, don't get hung up on the letters. I just picked some letters. All right, so now we're going to do just a little bit of algebra, right? Wouldn't this be, if we can multiply this out, this would be b squared over r squared. And this would be a squared over r squared. Okay, fine. Okay. So what do we get if we add these? Well, check it out. This is a fraction problem where the denominators are already the same. So what that means is we can add the numerators, b squared plus a squared, and put it over that common denominator, like we always have. All right, so we've done all this work. We've taken this long walk. We've ended up with b squared plus a squared over r squared. We're getting so tied up in stuff. Let's take a break and remind us, what is b squared and a squared? Well, look at this. Look at the original thing right here. Look at that. Where am I pointing at it? Can I right over here? You see that? Yo. All right. So b squared and a squared, think about this, man. It's like they're talking about the Pythagorean theorem. B squared and a squared is r squared, right? Because they're the three sides of a Pythagorean triangle. So if we look at this, b squared plus a squared, that actually is r squared. And if we do r squared divided by r squared, I guess I should have some equal signs in here just to be pretty. And if I do r squared divided by r squared, we get 1. So what just happened? This is the proof that for any angle, because remember, I just picked an angle at random. There's nothing special about this x. For any angle, if we square the sine, square the cosine, and add them together, no matter what the angle is, it'll always simplify to 1. So that's how they got that in this problem. I thought that was pretty neat. So there you go, online. You're welcome. All right. Next. So I think maybe we have time for 2 more. Let's see. We'll see if we got time for 2 more. I'm excited. Let's see. This one, man, it's just the tiniest bit cut off. We gotta take that back into the lab. All right. So this was somebody that asked this question online. I'm happy to answer it. So let's take a peek. The person says, so I have this question. And it goes, factor for the GCF and write out as a simplified binomial 8x minus 40. All right, so how am I supposed to do this? I have no idea how to find a GCF on a question like this or how to find one at all, really. Okay, so the greatest common factor is what is the biggest thing that goes into 8 and goes into 40. Okay, so GCF, I'm going to help this person out. So it's a question mark, right? Ooh, I can even do that. Biggest number that goes in to 8x and 40. That's what we want to know. All right. All right, so let's look. What I'm going to do, just, to be like totally transparent, is let's talk about like the ways that we can break down 8x. So let's see, 8x, I mean, I'm thinking 2, 4, 8, right? Those are the numbers I'm thinking. 40, I can do 2, 4. Oh, so let's stop there. 8x and 40 both have a 2 in common. So 2 is a common factor. 8x and 40 both have a 4 in common. 4 is a common factor. However, 8x and 40 actually both have an 8 in common. And 8 is the greatest common factor. How do I know 8 is going to be the greatest common factor? Because if I can factor out an 8, I can't go any further. Check this out. If I have an 8x and I factor out an 8, I'm left with an x. If I have a minus 40 and I factor out an 8, I'm left with a minus 5. Now look at those two terms, x and minus 5. Those don't have anything in common. So there is nothing else we're going to be able to pull out of that. So what we just did is we just identified the greatest common factor, which was 8, and then we factored it out to write what your teacher called a simplified binomial. Groovy. Look at that. Not all the questions are long, right? Okay, let's see. Maybe let me look at my last couple questions here. Let's end on this one. I'm going to pick this one to end on. I thought this was cute, man. So if you go online, right, and you check out the homework help Reddit, which now is like my bread and butter, that's where I'm getting these problems. It looks like a whole bunch of teachers gave like brain teasers to kids this week, being like the first week back from break. It's kind of funny. Like they all ask these weird questions, and I think the teachers, I don't know what maybe they're in the back of the class with sunglasses on. I don't know, man. So let's talk. This one says, find an example. This is like a creative problem. Find an example of two irrational numbers a and b. So we need two irrational numbers a and b, where a and b are not equal, but a over b is rational. So a divided by b is rational. Is rational. All right. So this is a problem. I love this problem because this requires a whole bunch of creativity. I'm just going to give an answer. And then, because I think once you see the answer, you're going to be able to generate like a million problems just like this. So let's talk about it. Rational number is just a fraction. It can be expressed as a fraction with an integer on the top and an integer on the bottom, right? An irrational number cannot be expressed as a fraction. And let's not get too tied up in it. Let's also go to like an example of an irrational number, which is like a pi or a square root of 5, right? Some kind of ugly square root. Those are the irrational numbers. I'm just going to use pi. Why not? Let's use pi. Let's play with pi. Here's the answer that I'm going to give. How about this? If a is 5 pi and b is 10 pi. Check me out, bro. And dudette. So a is definitely irrational, right? It's 5 times pi. B is definitely irrational. It's 10 times pi, right? So you know it's 31.4 blah, 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 forever. But what happens if we divide them? What happens if we do a over b? We get 5 pi over 10 pi. And guess what happens, man? Cancel city. Not only do the pi's cancel, but 5/10, that turns out to be 1/2. So I picked two irrational numbers that when you divide them, not only do you get a rational number, you get like the easiest rational number, you get 1/2. How about that? Now can you generate like 50,000 more of those answers once you see one of them? I bet you can, and I bet you can find some uglier answers in that too. All right, everybody. It is pure magic. It's pure magic. So I'm going to turn up my killer drum beat. Hopefully everybody is really vibing to this drum beat. I made it myself. It definitely sounds like a drum beat made by a math teacher. That's it for tonight. We're probably going to take Monday off because of Martin Luther King, but we will be back Tuesday at 9 for Everyone Loves Math Live. Come on back.